All right, let's do lesson 22, graphing linear inequalities in two variables. This is part 2. So, landscaping options. A homeowner is making plans to landscape her yard. She plans to hire professionals to install grass sod in some parts of the yard and flower beds in other parts. Grass sod installation costs $2 per square foot, and flower bed installation costs $12 per square foot. Her budget for the project is $3,000. Write an equation that represents the square feet of grass sod X and the square feet of flower beds Y that she could afford if she used her entire budget. So, what's the maximum amount she can spend? It's going to be that $3,000. That's her budget. So we're going to say $3,000. That was a funky looking 3 there. I'm going to redo that. $3,000 equals, so it is $2 per square foot of grass sod. Grass sod is going to be X square feet. So we're going to have 2X plus, then we are going to have, let's see here, then it is $12 per square foot of flower bed. And the square feet of flower beds is going to be Y. So there's our equation. On the coordinate plane, sketch a graph that represents your equation, and then be prepared to explain your reasoning. So, on the coordinate plane, let's see here. So I'm going to take my equation and I'm going to put it in slope-intercept form. Okay. A reminder, slope-intercept form is y equals mx plus b. So I forgot my y over here. So all I need to do is get my y isolated. So what I'm going to do is I'm going to subtract my 2x right here from both sides. So I'm going to get 3,000 minus 2x equals 12y. Then I'm going to divide by 12 on both sides. I'm going to get 250 minus 1/6 x equals y. This is slope-intercept form. It just is the opposite direction. This is y equals mx plus b. Okay? All right, so my first point is going to go to 250. Then we're going to go down 1, and to the right 6. 2, 3, 4, 5, 6. And then we're going to do that one more time because I like to have more than one point. 1, 2, 3, 4, 5, 6. To make sure my line is nice and straight. We are freehanding this, so it's not going to be super straight. And I'm going to go ahead and do my last point, which should be, hold up, I think I messed someone up there. 1, 2, 3, 4, 5, 6. There we go. Should be right there. So then you're going to connect your dots. If you have a ruler, it would be best to connect them because, see, my line was not very straight. Okay. Sketch a graph that represents your equation. We did that. Be prepared to explain your reasoning. Well, be prepared to explain your reasoning is you put it in slope-intercept form, you found the intercept, and then you did the slope. So we'll go to the next page. Rethinking Landscaping. The homeowner is worried about the work needed to maintain a grass lawn and flower beds. So she is now looking at some low-maintenance materials. she is considering artificial turf, which costs $15 per square foot to install, and gravel, which costs $3 per square foot. She may use a combination of the two materials in different parts of the yard. Her budget is still $3,000. Here's a graph representing some constraints in this situation. The graph shows a line going through 500, 100. So, in this situation, what does the point 500, 100 mean? So, I'm going to take this and I'm going to go over to my dot. I'm going to make dots all the way down. So, we have 500 square feet of gravel. And we have 100 square feet of artificial turf. So, we have 500 square feet of gravel and 100 square feet of artificial turf. That means that she can purchase that much, so 500 square feet of gravel and 100 square feet of artificial turf. And that will cost $3,000. All right. Write an equation that the line represents. So, our line is going to be, so we have $3 per square foot of gravel and $15 per square foot of turf. So my gravel is going to be 3x plus 15y. I'm using x for gravel because it's on my x-axis, and y for artificial turf because it's on my y-axis, equals 3,000. What do the solutions to the equation mean? So the solutions to the equation mean that the amounts of gravel and artificial turf that can be installed for, that's an S, for $3,000. All right. Number 2, the point 600, 200 is located to the right and above the line. Does the combination of turf and gravel meet the homeowner's constraints? So I'm going to do this one in blue. So 600, 200. We can see the point up here. Does this point meet the homeowner's constraint of $3,000? It does not. No. Because it will cost more than $3,000. To prove that, you can say 3 times 600 plus 15 times 200 equals 3,000. 3 times 600 is 1,800. 15 times 200 is going to be, I believe that is 3,000. We can see, oh, wait, yeah, that's right. Okay. We can see that this is going to cost way more. So this does not equal 3,000. Okay, it's going to be more. It should be 4,800. Okay. Choose another point in the same region to the right and above the line. Check if the combination meets the homeowner's constraints. So I'm going to go up here. I'm going to pick another point. Let's say 250, 1,000. Let's pick the farthest point up there. So we choose 1,000 to 250. We plug it into our equation. We have 3 times 1,000 plus 15 times 250 equals 3,000. I know that 3 times 3,000, or 3 times 1,000 is 3,000. Let's see here. 15 times 250 is 3,750. Both of these numbers are above 3,000, so it does not meet the constraint. Does not meet the homeowner's constraint of $3,000. All right, let's go to the next page. The point 200, 100 is located to the left and below the line. I'm going to go back over to my graph down over here. I'm going to use purple this time to mark this point right here. So 200, 100. So we see that it's to the left and below the line. Does that combination of turf and gravel meet the homeowner's constraints? So I'm going to go ahead and just plug it into my equation and see. So we had 3 times 200 plus 15 times 100 equals 3,000. So we're going to get 600 plus, let's see here, 1,500. We add those together, we're going to get 2,100. Is this a true equation? Is 2,100 equal to 3,000? It's not. But does it meet the homeowner's constraint? Is it within their budget of $3,000? Yes, because it is less than 3,000. So, yes, it meets the homeowner's constraint of $3,000 budget because it is less. Choose another point in the same region to the left and below the line. Check if the combination meets the homeowner's constraints. All right, I'm going to pick, let's see here. Let's do last hour they wanted to do 0, 0. So I don't think I want to do that because that's not realistic. But let's see, we already did 100. That one's easy. Let's do 5,400. So 50. Did I do that backwards again? I did. 450. Okay. So we're going to check if the combination meets the homeowner's constraints. So again, we're just going to plug it in. We're going to have 3 times 400 plus 50. Sorry, 15 times 50. All right, so we're going to get 1,200 right there. 3 times 400. 15 times 50 is 750. So we're going to add those two together, and we're going to get 1950 equals 3,000. So it does meet the homeowner's constraint. Because it is less than $3,000. So I'm going to go in and I'm going to change these signs because it's less than or equal to. Less than or equal to. So with changing that, do you guys see that an inequality that represents the constraint in this situation? And then shade, let's see here, and then show the solution region on the graph. So I'm going to write down my equation that I had earlier. So that I'm going to have the 3x plus 15y equals 3,000. But I'm going to change it to be less than or equal to 3,000 because all of the solutions that were less than our line on the last page gave us less than the budget. So the budget is a maximum of $3,000. So if I go back over to my last page, I'm going to shade here. I'm going to shade all of this because all of these are solutions to this equation. So I got a little bit over the line there. Not on the other side of the line. I'm going to go back and erase it because I don't want you guys to do anything on the other side of that line. So let's see here. I'm going to get as close as I can and try not to go over the line. Those are all of your solutions. Let's see here. We're going to go ahead and skip basically the rest of this lesson because they're similar equations. These would be good if you need to work on like practice problems and if you need help. So email me if you have any questions.